Here is a question on trigonometry from the EGCSE Mathematics paper 4. Question number 4. Let's check it. Says the diagram shows the quadrilateral ABCD. And then you are required to calculate the length of AC. Let's check. AC, it's this one. So to find that length, let's check what do we have. We have an incomplete pair, like that, which simply means since we have an incomplete pair, and the other two sides here, this one and this one, we are supposed to use the cosine rule. Let's use the cosine rule for this question. So we are going to say AC, use capital letters, squared. AC squared, this is equals to 7 squared plus 5 squared minus 2 times 5 times 7 cos 153. And then your AC squared is equals to 7 squared, that's 49, 25 minus 2 times 5, it's 10 times 7, that's 70 cos 153. Then from there, 49 plus 25 going to give you 74 minus 70 cos 153. Now let's use a calculator for that. We are getting 136.37 136.37, and then to 3, let's take the square root of that. The square root is going to give you 11.67 meters. Sorry, it's centimeters, not meters, centi. Next question, that was question number B. Question number B requires us to calculate the angle ACB. Angle ACB. Let's check. Angle ACB, it's this angle here. ACB is angle here. From there, what do we have? Let's check. Don't forget you have already have your 11.7 here. And then you want that angle. So 153 and 11.7 now gives you a complete pair. And this one is an incomplete pair. So for that, you are going to use the sine rule. Let's find it. Sine, what's that? AC. B over side opposite to that angle, it's 7. This is equals to the sine of 153 over 11.7. Multiplying by the denominator 7 on both sides, you are going to get that your sine ACB is actually equals to 7 sine 153 over 11.7. Let's use our calculator for that. Maybe I should be showing you the calculator here. Just a moment. All right, here is our calculator. Now let's find that. And again, for the 11.7, we are going to use our previous answer, which was 11.677777619. So this is what we wanted to calculate. So instead of this one, we need to use the 11 point something. Which was this answer here. Instead of the 11 points, let's use the complete answer here. So it's giving us a 0.272, which means now we have our sine, being equals to that. This is it, sine ACB is equals to the 0.22 at what? Then the ACB will then be equals to the arcsine. Let me write arcsine in words, which is the same thing as the actually the same thing as, let me bring in my calculator. There you go. Let's just put that. And this is the angle we are getting, 15 point. We are getting 15 point. Let me go. So the ACB is equals to 15.79136093, which is approximately, to 3 significant figures, it's 15.8 degrees. Next question. Let's find angle ACD. Angle ACD, let's check which angle is that. ACD. It's this angle here. So how do we find that angle? We have a right angle triangle. So we are going to use what? The SOHCAHTOA. Let's use SOHCAHTOA for that. What does it say? The angle, it's a CD. And then opposite to that angle, it's AD, and we have got nothing to do with AD. Adjacent at 6. So you have an adjacent side, which is 6. The next side, we have the hypotenuse. That's 11.7. So we have an AH. So we are using cos ACD. This is equals to adjacent, it's 6 over hypotenuse, it's 11.7. And then to find the angle there, let's do the arc cos ACD. It's equals to the arc cos 6 over 11.7. I know some of you, they are not familiar with the term arc cos, arc sine, arc tan. It's actually the second function of that ratio. And then it's normally written cos with the power negative 1. That's actually it. And so let's put this one in a calculator. Let's go to our calculator here. And put that. Why did I copy? Seems like I didn't copy it well. Let me put it. Nice one. And again, for the 11.7, we are going to use the complete number there, which was 11.69 something. And then for your calculator, you're just going to be scrolling up until you find that angle. So it's just that, like this. And then 559.08, if you used 11.7, you are getting 59.14, which is something quite different. So you are always advised to use the number from your calculator. Let's go back to our working space. Now, oops, I'm already closing. Maybe let me stand this. Okay. Okay. So now let's work. AZD is equals to at, and then angles are always correct to 1 decimal place, so it's 59.1. Now let's take this down there. Just 59.1. Then you get your 2 marks. Then for the CAD, angle CAD, how do you find angle CAD? So to find the angle CAD, let's go to here. You'll see it's actually the other angle in the right angle triangle. So we are just going to use sum of angles in the right angle triangle there. That one there, we are going to use the sum, and then you are going to easily find a solution there. So actually, let me work on that like this. Sorry, I don't need you again. We have a 59.1 on a ABCD plus 90 degrees plus the angle that we are looking for. Let me call it A. This should give me 180, sum of angles in a triangle. And then that is going to give us what?